To find the integral of tan x, you might think of writing tan x as sin x over cosine x. Generally, that's what we do. We want to convert everything to sines and cosines. And especially if you know the integrals of sine and cosine, this is the natural first step. But here is the thing. If I want to integrate tan x with respect to x, now I'm going to write this as sin x over cosine x. Now, unlike the process of differentiation where we had quotient rule, so whenever we want to take the derivative of tan x, if we don't know what it is, we could apply the quotient rule and use these derivatives and plug it in. But there is no such facility when it comes to integration. Then what else can we do? Now here is what we notice. We notice that the derivative of sine is cosine and that of cosine is sine. And we also know that if I have something like 1 over x, then I can figure out its integral. So if I let this be some other variable, so say the denominator, I don't want to have cosine x, but I want to have just another variable, u. Then what I'm trying to say is I don't want to deal with x anymore. I'm going to deal with this variable u. But I can't be integrating something, some function of u with respect to x. I want to integrate with respect to u. So the first thing I want to do is I want to figure out du over dx, and that is negative sine x. Now let me remind you, du over dx does not mean you're dividing du with dx. It's just a symbol that says that you're taking the derivative of u with respect to x. However, it requires some bit of analysis to prove, but you can always multiply both sides by dx. So I don't want to say that I'm multiplying both sides by dx, but here is how I would say it. I would say if du over dx happens to be negative sine x, and after that steps in analysis I take, I could write du as negative sine x dx. So it looks like you are multiplying both sides by dx. Now this thing works, and that actually forms the basis for integration by substitution. Whenever you are substituting for a different variable, you want to use a different variable like u, then to get du you could do that. Take the derivative and multiply by dx. Now these are called differentials. Du over dx is the derivative of u, du is the differential of u. So what happens now is you have integral, look at the numerator, you have sin x times dx. That's opposite of du. So if I multiply both sides by negative 1, I get negative du equal to this. And negative can be pulled out of the integral. Any constant could be pulled out. And then you have divided by u, because cosine x is u. And that was the whole point. We wanted to have just a variable in the denominator. And you might recall that this is going to be negative natural log of absolute value of u plus c. So we integrated and we got this answer. But this is a function of u. We want to change it back to x. So we replace the u with cosine x. So this is negative log of absolute value of cosine x plus c. Now, in some books, you might see a different formula because they have used the properties of logarithms from algebra. You know that you could rewrite this as ln of cosine x to the negative 1, and cosine x to the negative 1 is just the reciprocal of cosine x. So that's going to be secant x. And then you won't have the negative in front. So that's the derivative, or sorry, that's the integral of tan x, natural log of absolute of secant x plus c, or equivalently negative log of absolute of cosine x plus c.